right, everyone. So this week is week 2, asynchronous, and we have a few things to do today. Obviously, watch this video, learn a little bit more about EDA and big data. And then we are going to be working on our dplyr verbs. And that is a refresh. So watch those videos after this one. And please message me with any questions. I will be in a in-person training all day, so I might not be able to answer them right away. All right, so this week we're exploring exploratory data analysis, often called EDA. So EDA is how we get to know a data set before we do anything fancy with it. And when we talk about it, EDA becomes even more important for big data because we can't just scroll through the data or look at every row by row because it's so big. Instead, we really need to think like an explorer, use our summaries, use visuals, and ask questions to understand really what's going on. So what's meant by, what do we mean when we say explore data? When we say explore, we don't mean randomly clicking buttons or immediately running models. Explore really means to be asking questions, to look for patterns, to check whether the data makes sense, and understand what the data can and cannot tell us. Really think of EDA like meeting someone for the first time. You don't just jump straight into deep conclusions. You start by learning the basics. So EDA is the first step in any data analysis process. So whether you're doing predictive analytics, whether you're doing any types of machine learning, deep learning, etc., we really need to get to know the data. We don't form a hypothesis and then go through because we don't know the data. We need to go through and we really need to explore and look for patterns, identify outliers. And outliers are those random things that are happening. Think about salaries. And I work in education, so I think about this a lot. Teacher salaries. Sometimes we have an anomaly where teacher salaries are about $3,700 to start, $3,800 to start a year in North Carolina. And then you might have an anomaly where somebody's making $100,000, and that would be an outlier. Then we check for missing data, missing values. We make missing values in R appear differently than they appear in Python and how you work with them. And so in checking for missing values, we'll do that. And then how we handle them is a little bit different than Python. But then we make sure the data is usable. We generate ideas or hypotheses after we go through all of this, and we do that for formal statistical or formal modeling, which we are not going to be doing in this class. We are not doing any formal modeling, but we will, towards the end of the class, learn how to generate a hypothesis based on exploring our data. And in big data, this step helps us avoid expensive mistakes later, which is really important for our stakeholders, right? So asking the right questions, and we'll be doing this throughout the whole course. Asking the right questions in EDA, again, exploratory data analysis, we're asking really, what does our data look like overall? Are there any strange values that shouldn't be there? Is anything missing? Can I trust this data? You're not trying to be right. You are trying to be curious. So and in data science in general, that's our nature. We're curious about what's happening. I wonder this, I wonder that, I wonder what's happening here. And so you might go through exploring the data for the first time, and then you're like, I wonder why these two variables look like this and how they interact. So, it's all a big exploration. And there are some steps that we go ahead and we kind of do. And so we start with raw data, and typically we have a couple different data sets. So if you have raw data, you always keep that one data set as the raw data so you can go back there. And you don't overwrite that raw data. So whether you're working in R, in Python, in Excel, if you're working in Excel, you should always have one tab that has raw data, and then the other tabs after that can be a copy of that raw data that you manipulate. But here we have raw data, then we're cleaning the data. And part of cleaning the data is really where we're doing some exploratory data analysis. It happens really early. And then we get like the description and visualization happening. Here we're descriptive analysis. Then we're looking at an adjustment of any variable types, and we're going to be getting into that. We'll be looking for missing data. And then we're going to be looking for any identifying atypical data. And then we can look at correlation of some variables. Again, this is not formal. We are looking to see if some variables are correlated, how they're correlated, and then we make some conclusions and kind of come to a hypothesis. And so these are pretty much the EDA steps under exploratory data analysis. So again, it's not one step, it's really a process that you return to often. And typically, even when you start wrangling your data, even if you have a hypothesis, you might come back to the exploratory data analysis step. But for us, we're just thinking about this as a first, exploring the data, getting to know the data, what's happening with the data. Again, here's some more information on steps to perform EDA. First, we do the data collection and cleaning. We handle missing values and obvious issues. Second, we're looking at descriptive statistics, sometimes through tables, other times through visualizations. We'll calculate simple summaries and make simple plots to understand distribution and relationships. In R, we'll be using ggplot. And if you're not familiar with ggplot, it is also part of the tidyverse, which we'll be talking about in a minute. And finally, the third is pattern identification and hypothesis generation. We start noticing trends and asking, why might this be happening? And at this stage, really, questions are more valuable than answers. And here are really three major categories of EDA techniques. So we have summary statistics, which we've talked about. This is where we're doing things like averages, spread, and typical values. Then we're going to have data visualization. This helps us see the patterns better that numbers alone might hide. And we can use different charts, and there's different chart types for different types of data that we're using. And finally, we have dimension reduction, which becomes important with big data when there are many variables. And we're actually going to be using correlation to go ahead and look at this. We are not doing PCA in this specific class. But there are different dimension reduction methodologies that you can use. And really PCA, you might see this more in your machine learning class or maybe some of your advanced statistical classes. So what makes big data big? Big data isn't just a lot of rows. And you've probably thought about this before. It's big because, and we talked a little bit about this last week, how much data there is, or how fast it arrives, or how many different types of data exist. So EDA helps us slow things down and make sense of that complexity. And really there are these 3 V's. Sometimes you'll see 5 V's, but we're just going to be looking at the 3 V's of big data. So it really has to do with the volume, which we have here at the top. And that's the large amounts of data. And so that could be click streams, how many people are clicking on a website at one time. Could be gathering customer feedback. Could be different loops that are happening and generating data. Then we have velocity, which is the data generated quickly or continuously, kind of similar to what we were talking about volume. The speed of generating that data today is so much faster. Think about on TikTok how many people click on one video, how long they watch that video, are they engaged, were there links within that video that they clicked on, did they buy something from there, all from one video. There's a lot of different data that you could generate to learn from. Was it a certain time of day that people are looking at it more so than others? What day of the week are they looking at it? What about it, the month? What month were they looking at it? The day, the time, the year. I mean, all of these things matter. And then also you might be thinking about, like, what about what was happening in the news that would maybe make them click on it? So there's all different things. So that book comes into the variety, different structures or unstructured data. And we'll be talking about that more going into the class. And so we're not going to get into that super here, but then in the class we will talk more about variety. What is structured data and what is unstructured data? So EDA really helps us understand which of these matters most for the data set we're working with, and who is the stakeholder. And you're going to hear me talking about stakeholder over and over and over again. So here are some challenges in big data. So data might be too large to load into memory, and it really depends on the computer that you have, and we're going to talk about that again. Visualizations can get cluttered by having too much data. Quality problems get amplified. And so there's all these different challenges. Data quality, traditional tools may be inadequate. So some of the solutions that we have are implementing distributed computing frameworks. Maybe some of you are taking Apache Spark for big data. That would be more of Apache Spark is more distributed computer, where the data gets distributed across a few computers. We could use dimensionality reduction techniques, adopt streaming analytic tools, develop data cleaning pipelines, and leverage special big data tools, which we'll be doing in this class. Best practices for working with big data, making sure that they're sampling before analyzing everything, using tools designed for large data, letting computation happen where the data lives, and using visualizations that scale. In this course, we'll focus on practical strategies, not just theory. Again, this is a 1-credit course, 50 minutes. Manage your expectations for this class. There's things you want to dive deeper in. Of course, there's plenty of things out there that you can. Or take a 3-credit course. And really, there's 3 common strategies for working with big data. You can take a sample and model. You can chunk and pull. You can push compute to data. That's where you're letting databases do the heavy lifting. Chunk and pull is really where we're processing data in pieces. And again, sample and models, that's where we work with smaller subset first. And we have different packages or different software that help us do all of that. Our class is mainly on Arrow, using the packages Arrow and DuckDB. Again, we'll be talking about that more in I think week 4 we get into Arrow. Again, so we have different tools. So for data manipulation in R, we're going to be using dplyr. You might have also heard of data.table. That one is fast aggregation. It uses more SQL language in R or wherever you're using it. And then we have tidyr as well. Tidyr is good for tidying and reshaping. dplyr is efficient for data manipulation and transformation. We're going to be focusing on dplyr. For visualization, we'll be focusing on ggplot2. We are not going to be using Plotly. That is interactive. If you want to use that for this class, you're welcome to use that. That's just another package. that makes your visualizations dynamic and interactive, where you scroll your mouse over, it can show like the different data points. Leaflet is really for interactive maps. And then for other big data, there's Sparkler. That's using Apache Spark. We actually have another class that does that. And then for us, we're going to be using Arrow, and also, which is Apache, but also DuckDB. And we're not using SQL for DuckDB. Arrow and DuckDB, we are using dplyr verbs, which is why it's really important that this week you make sure to go through your verbs and you practice. Okay, on to the next video.